Good morning, and thank you, Andy, for that introduction. I'm Keith Thompson from Digital Vision Systems in Atlanta, and the title of my talk is Bringing Innovations to the Patient, the Last 10 Feet, with the VisionOptimizer. This is a new technology we are developing that will provide doctors with a superior refraction capability, patients with a novel experience, and it will be a profit-generating tool for your industry. The optical industry is teeming with innovation today. We've got freeform technology, tremendous advances in progressive lens design, all types of new coatings, photochromic, anti-reflective, and other things, and new multifocal designs for presbyopic and cataract patients to manage presbyopia. So the problem is not innovation. The problem is there's an obstruction to bringing these innovations to the patients and the consumer in the last 10 feet of the exam lane. What is that obstruction? It's the phoropter. And just by inspection, we can tell it's been around a really long time. It's got a lot of inertia, and it's not going anywhere easily. But let's not beat up too much on the old beast. It's really a remarkable device that's had quite a good run. The phoropter is to vision care what the stethoscope is to medicine. It's ubiquitous. It's elegant in its simplicity, and in skilled hands it can achieve great results. But the phoropter also has some inherent limitations. It has error-prone steps that can cause inaccurate or suboptimal prescriptions. Its fixed power lenses now provide far less resolution than freeform lens technology can provide. It has no ability to demonstrate products, progressive lens, photochromic, or other premium features to patients, making it difficult for the patients to appreciate the value these products can offer them. And even the most ardent defenders of the phoropter would concede that it doesn't provide consumers with a 21st century experience. So the VisionOptimizer is being devised to address these and other deficiencies. And since this is a forum about innovation, I'd like to briefly share with you the story of how the VisionOptimizer came about. After my residency at the Bascom Palmer Eye Institute in Miami, I was working in refractive surgery research on the first generation excimer laser technology. The laser hadn't been approved yet, and we were still in clinical trials. We found that in many cases, refracting patients with a phoropter was wholly inadequate in explaining our postoperative outcomes. Let me give you an example. Patient J.K., age 52, who was a low myope, underwent excimer laser surgery. 3 months after treatment, he was plano with excellent distance vision, and he could read J1+, the smallest letters in the phone book. Boy, was he happy. He couldn't send his friends and family to us fast enough. Another patient, age 50, was also a low myope, had surgery with the same laser, the same surgeon, in the same facility. His outcome was different. He didn't see as well at distance, and he couldn't read without a big reading ad. Worse, he couldn't drive at night. So despite these very different outcomes, the postoperative refraction with the phoropter was identical. Clearly, it didn't explain what was going on. As a research fellow, I had the good fortune to work with some very smart optical physicists from Harvard and MIT at the Scapin's Eye Research Institute. We developed a technology called spatially resolved refraction. Unlike the phoropter, in which the refraction is averaged across the entire pupil, we devised a way to do a simple manifest refraction through many different points on the pupil. This is a technology that also measured the entire visual system encompassing the eye and brain interactions and the perception of vision. We added an eye tracker to this technology, which remarkably enhanced its accuracy. When we use spatially resolved refractometry to evaluate these postoperative patients, it explained the treatment outcomes. As you can see in our patient who was so happy that we cured his presbyopia, the spatially resolved refraction map shows that we had carved a progressive corridor perfectly over his pupil. Weren't we clever? This technology allowed us to devise new laser ablation profiles that improved outcomes in LASIK and PRK surgery. We also developed, using the SRR, we also developed a method to demonstrate to patients what they could see with a particular treatment plan. And this was very useful to patients and surgeons. But this technology lacked a binocular vision testing capability, and therefore we thought that it had limited commercial potential until we found a way to add those features to our technology. Being a refractive surgeon always groveling for referrals, I was visiting an optometrist friend one day in his clinic and noticed that he was refracting patients without a phoropter or even trial lenses. I was amazed and thought that he had just acquired a new instrument that I hadn't even heard about. But in fact, that instrument was over 30 years old. It was called the Humphrey Vision Analyzer, and it featured the first ability to refract patients without obstructing instruments and used adjustable lenses that were remotely relayed to the patient's spectacle plane. I knew immediately this was the perfect binocular vision testing platform for our technology. We then integrated our SRR system into the HVA's architecture and built our first VisionOptimizer prototype and tested it in our clinic. We were blown away. Not only did it outperform the phoropter and make measurements that were more accurate and more reproducible, we could take spectacle-wearing patients off the street and show them improved vision in 90% of cases. The patients loved the novel experience free from any obstructing instruments or the need to guess which is better, one or two. Patients and doctors preferred the VisionOptimizer over the phoropter by a wide margin, and a number of doctors even gave us deposits to be first in line when the instrument was ready. Based on the results from this prototype, Digital Vision was then selected by the Georgia Tech Venture Lab program, an incubation program that selects technologies thought to have commercial potential. This gave us both financial support and, more importantly, access to some very smart engineers at Georgia Tech's Electro-Optical Systems Lab. The engineering team set about to design the VisionOptimizer for clinical introduction. Let me give you a brief tour of the instrument and how it works. At the core of the VisionOptimizer is what we call the wavefront generator. This generates the image and can vary the focusing power during the exam. Images are created by a high-resolution organic light-emitting diode that can produce very rich colored images. They're then projected into the wavefront generator, where continuously variable power lenses can impart the refraction to 1/100th of a diopter resolution. The image with the corrective optics is then relayed to the viewing mirror. A spatially resolved refractometer is integrated into the wavefront generator to provide higher resolution refractive measurements across the pupil. The viewport mirror is where the patient sees the image. It provides patient a wide field of view, and the viewport mirror is what optically relays the corrective lenses to the patient's spectacle plane. This provides natural viewing conditions during the exam, and the patient's free of obstructing instruments. The eye tracking system, which works on 2 stereo cameras in the viewport, greatly increases the accuracy of the exam and allows the patient to move about normally during the testing. By directing the viewport mirror downward, the beam is directed through the near viewing plate to permit near vision testing. An interactive haptic control, like the one you use to control the electronics in your car, allows the patient to provide feedback during the exam. It also allows doctors to delegate more of the refraction, which is going to reduce chair time and improve the efficiency of the exam. Of course, you can generate conventional eye charts in the viewport mirror, but as you'll see in the video, most doctors will probably choose to generate images that are more lifestyle relevant to the patient. Another interesting feature that we devised is called Preview, Compare, and Select. Each eye has 2 wavefront generators. This allows us to show side by side two different prescriptions or even two different product designs. In this way, patients can be shown the benefit, for example, of a new freeform technology over a conventional lens. We also can use it to demonstrate the improvements that particular optical coatings, such as photochromics, could add, and this should be a useful tool to upsell patients to premium product features. Let's take a quick look on this video and a tour of the VisionOptimizer. The system is being designed to fit in a conventional 8 by 10 foot exam lane, leaving plenty of room for equipment stand and a slit lamp. When looking in the viewport mirror, again, conventional eye chart images can be shown, or you could test acuity by showing soccer moms pictures of kids, or college football fans the picture of their favorite team. Here the eye tracker is shown, and notice that it finds the patient quickly and it keeps the beams aligned with the patient's eye during the test. This allows normal movement during the exam. To simulate progressive lenses, the design is loaded into the wavefront generator, and because the system knows which portion of the progressive lens the eye is looking through, the wavefront generator can be dynamically adjusted in real time, giving the patient an idea of what the progressive design will be like during wear and head motion. Any PAL design can be simulated with this technology. And we're also not limited to static images. You can show high definition video through the prescription driving at night and in other settings. So, that's a brief overview of the system. Our status is as follows. We've completed our Generation 3 prototype testing, and we are now building the alpha unit at Georgia Tech with all of the full feature sets that I just discussed. We'll be entering alpha trials later this spring, in which we will perform a formal clinical trial of the performance of the instrument against the 4-opter and products, including single vision and progressive spectacles, made with the VisionOptimizer versus conventional means. In the fall of this year, we'll have beta units ready for doctors who wish to beta test and with our research partners, and we intend to complete the industrial engineering at Georgia Tech and our manufacturer and be ready to make production units with market entry next year. So in summary, we believe the VisionOptimizer provides a superior refraction capability with accuracy to 1/100th of a diopter, resolution enhanced by higher order aberration measurements by spatially resolved refraction. It's a true dynamic binocular refractometer, and the measurements are highly reproducible. Patients will have a totally new experience. It's actually a fun test. They like it. Natural viewing conditions, free of obstructions, normal movement, and patient ECP supervised and patient interactive capability. We believe the VisionOptimizer will provide your industry with a profit-generating tool. You can use it to upsell patients to premium products, preview and compare and select the best prescription, provide proprietary prescriptions, and improve efficiency and reduce chair time. Thank you for your attention.